Good afternoon and welcome to Science. Today we are going to talk about the second section of Chapter 2, which is all about the nervous and endocrine system. The other day, during our last class, we started talking about the nervous system and the components of the nervous system, the various kinds of nerves, right? The sensory nerves, interneurons, as well as the motor neurons. All right. We also talked about how signals are transmitted from one end of a neuron to another, as well as from one neuron to another. Today, we're going to continue that discussion, but move more into the organ system level. How does the nervous system work? And in addition to that, we're going to talk about hormones, because your hormones produced by your endocrine glands are also a very important aspect of communication within the body. So we're going to start today with a discussion of the nervous system, and you can see a schematic diagram with a flow chart here on the right talking about the various divisions in the nervous system. If you look very carefully, you can see that there are two major divisions, the CNS, or central nervous system, and the PNS, or the peripheral nervous system. Now, the central nervous system consists of the brain and the spinal cord, all right? And the vast majority of neurons that you find here are the interneurons. This is where the processing of information, the integration of data is actually taking place. The peripheral nervous system is composed of the nerves that go throughout the rest of the body, and they deliver messages from the body to the central nervous system and from the central nervous system back to the body. Now, the picture here shows the brain up top, as well as the spinal cord running right down the middle. And you can see that there are lots and lots of branches of nerves coming out. And these actually are coming out from your backbone, through your vertebrae, all right? Where each vertebrae comes together, there's a gap, there's a hole here. And through those holes are where these, the spinal nerves and the cranial nerves exit the system. Now, the cranial nerves are mostly involved inside the head, and the spinal nerves come out from the vertebrae. So here's the central nervous system. All right, the cranial nerves go directly back and forth between the brain, and the spinal nerves go directly back and forth from the spinal cord. But of course, the spinal cord and the brain are also in constant communication. So there should be a double-sided arrow here as well. Now, both cranial and spinal nerves are composed of sensory and motor nerves, and you can see that shown down here. All right, and then as far as the rest of this diagram goes, we'll talk about the somatic and autonomic nervous systems and the sympathetic and parasympathetic nervous systems as we get a little bit further into this video, okay? But essentially, we'll start with the idea that there are two divisions of the nervous system: the central nervous system, which is the brain and spinal cord, and the peripheral nervous system, which are all the other nerves in the body. Okay, just as a brief reminder of the types of nerves that we're talking about here, the sensory neurons are carrying impulses from sensory receptors in your skin, your eyes, your tongue, and so on, and they take them and they carry them to the central nervous system, either the brain or the spinal cord. The motor neurons, and you'll notice, yes, I skipped the middle one here, but the motor neurons are taking impulses from the brain and spinal cord to what we call an effector, all right, which is a gland. Maybe it may be an endocrine gland, or a muscle fiber to make you, move, duck or move your hands, or, try to block yourself, or whatever it happens to be. All right, these are And the sensory neurons and the motor neurons are mostly part of the peripheral nervous system. Now, the interneurons, the ones in the middle here, these are really inside the central nervous system. These are the neurons that make up the brain and the spinal cord. And so they're taking information from the sensory nerves and they're sending information out through the motor nerves. Okay. So the central nervous system, as we've already said, consists of the brain and the spinal cord. But section 3 of chapter 2 deals with the brain in and of itself. And so here we're just going to talk about the spinal cord. Now the spinal cord spans from the stem of the brain, so right in the back of your head, right here, all right, all the way back and down, right through into the pelvis. All right, so from the stem of the brain down through the neck and the center of the spinal column, all the way down to your tailbone. And it serves as a conduit for both incoming sensory data and outgoing movement commands. All right, and so remember the three things we had: input, integration, output. All right, two of the three things are happening through the spinal cord. All right, the input of sensory data and the output of motor data. Now, for the most part, information that comes into the spinal cord goes directly up to the brain for integration and processing. However, there are certain aspects of our behavior and our physiology that require a very quick action, and these are often known as spinal reflexes. Now, a spinal reflex is a simple and automatic action of the spinal cord that doesn't require input from the brain. And there are a couple of them that are pretty prime examples. All right, the knee-jerk reflex. All right, if you've ever sat on your doctor's examination table and he's taken that little rubber hammer and hit the tendon directly beneath your kneecap, and all of a sudden you kick out your leg. All right, that's a reflex. That comes from learning to walk bipedally way back in our evolutionary history. Because if you are walking through the tall grasses and you walk into something, all right, what you're going to do is you're going to fall over, all right? And what are the most commonly broken bones in the human body? The ones that make up your arm, your lower arm, because you reach out and you try to stop your fall by blocking the ground with your hands, and you end up breaking your wrist. Now, in the old days, that could be a fatal injury. So what this reflex does is it makes you kick your feet out in front of you, so that you catch your step as you're tripping. You kind of catch yourself before you actually fall down. Another example of a spinal reflex is when you burn yourself. All right, I do this all the time. Whenever I'm stoking my wood stove in the wintertime to keep the house nice and warm, all right, oftentimes I'll hit the door of the wood stove or the frame of the door with the back of my hand or that kind of thing, and I always pull my hand away, and then it starts to hurt. Okay. In other words, I don't put my hand, like if this is the stove, I don't put my hand on the stove and go doopy doo. Oh, that's kind of hot. Maybe I should move my hand. All right. No, you touch the stove and you pull your hand right away, and then it starts to hurt. That's a spinal reflex. All right. The information is not processed by the brain until well after you've removed your fingers. Now, the peripheral nervous system is gathering information about the external environment and the body's internal environment. Right? It's the peripheral nervous system that tells you you're hungry, you're thirsty, your blood pressure's high, and that sort of thing. And it does this through the sensory nerves. And then it serves as a conduit for the motor impulses, the brain's commands to the rest of the body. But what you may not know about the peripheral nervous system is that it is also divided into two separate systems. We have the somatic nervous system and the autonomic nervous system. Now, the somatic nervous system carries commands from the sensory receptors to the central nervous system and relays commands from the central nervous system to the skeletal muscles. But the key here is that it is voluntary. All right. The somatic nervous system is all of the stuff that you actually think about. All right. If you want to yell at somebody, if you want to, give somebody the finger, not that you ever would, because you're nice, polite, little Catholic college attending students. So don't do that. But if you wanted to walk across the room or punch something or wave at somebody, these are all voluntary actions, and so therefore are controlled by the somatic nervous system. On the other hand, the autonomic nervous system regulates the functions of what in the name of all that is holy? The involuntary stuff, all right? The things that you don't think about, all right? Your heart rate goes up, you begin to sweat, you blink, you breathe, all right? All of those things are involuntary. You don't think about them at all. All right, it's not like you're walking down the street and going, my heart's only beating at 68 beats per minute. I think I'll bump that up to 72. All right, that doesn't happen. All right, your heart rate is automatically controlled by the autonomic nervous system. All right, so the major difference here is the somatic nervous system is controlling your skeletal muscles, your physical movements, whereas the autonomic nervous system is controlling all of the involuntary stuff, the stuff that you don't think about when you're going through your day-to-day life. Now, the autonomic nervous system is further divided into two parts: the sympathetic nervous system and the parasympathetic nervous system. Now, the sympathetic nervous system coordinates the body for what we call the fight or flight response, all right? And what this does is when you're scared or angry or highly emotional, it will respond by speeding up your metabolism, speeding up your heart rate, speeding up your respiratory rate, and all of the things that are necessary to stand and fight or to run like heck, all right? But at the same time, it downregulates the other functions, meaning that if you're trying to run away from a lion, there's no need for you to be worrying about digesting the last thing you ate, all right? It doesn't matter. And so blood flow will be cut off from the digestive system and sent to the muscles. And so the sympathetic nervous system carries out all of those kinds of functions to kind of boost your response to the fight or flight, okay? Whether you're going to stand and fight or run away. Now, unfortunately, you can't keep that up forever. And so when the danger is over or the emotional situation has passed, the parasympathetic nervous system then counters the sympathetic. And so it brings your metabolism back down to normal. It lowers your heart rate. It lowers your respiratory rate. And all of the other functions go back to normal. All right. And so this is all part of the autonomic nervous system. So the sympathetic ramps everything up and the parasympathetic brings everything back down. Whereas the sympathetic is known as the fight or flight response. Sometimes some people call the parasympathetic response the rest and digest response. It's hard to write with a mouse, sorry. All right, but rest and digest, okay? So fight or flight and rest and digest. Okay. Now, sometimes there are messages that need to be sent throughout the body that don't need to be sent really, really quickly. They don't need to happen immediately, okay? And so we have a second communication system involved in maintaining homeostasis inside the body, which we call the endocrine system. Now, the endocrine and nervous systems are separate, but they are connected. They do work together in a lot of different ways. Generally speaking, the nervous system is very fast. All right, nerve signals travel throughout your body at an amazing rate of speed. But the signals that are sent by the nervous system are very short-lived. They don't last long. Okay. On the other hand, The endocrine system is generally much slower, although there are some endocrine glands that are real quick. But the messages are long-lasting, including a lifetime. All right. For example, puberty. All right. I have 3 13-year-olds in my house, and guess what they're going through right now? Right. But the endocrine system, all of the hormones that are being produced there, take a long time to do the jobs that they're designed to do, but they last for a long, long time. In terms of puberty, it's a forever thing, right? Once you've hit puberty, you can't ever go back, right? I mean, think about that, right? When have you ever seen an adult go back to being a child? Not acting like a child, mind you, but actually physically being a child, all right? That may happen in science fiction, but it's not reality. So the endocrine system communicates using chemical messengers in the bloodstream, and these messengers are called hormones, all right? Generally speaking, the hormones are produced in one gland of the body, and they're carried by the bloodstream to a second gland, all right? And oftentimes that second gland will then release another hormone that affects a third gland, all right? But we'll keep it simple for today's discussion, all right? And because we're using the bloodstream as a method of transport, it's not nearly as fast as the nervous system would be. All right, because it takes a good 60 seconds or so for your blood to be transported all throughout your body, and that might be too late to duck if somebody throws a rock at you. All right, matter of fact, I'm pretty sure it would be. Okay. So this is a schematic, a drawing of some of the major endocrine glands in your body. All right, we have the hypothalamus, which is found up on the top here. All right, and this releases hormones that regulate the anterior pituitary. Come on now. And that's this area here. And notice it's directly beneath the brain. Okay, so it's working in concert with the brain. The pituitary gland is found here, just underneath the hypothalamus, and it's composed of 2 parts: the posterior, which is in the back, and the anterior, which is in the front. Okay, and there's a list of some of the hormones that it produces listed here as well. The thyroid is found in your neck, and this produces many of the hormones that are responsible for growth, development, and especially your metabolism. Your adrenal glands sit right on top of your kidneys, and they release corticoids, which are hormones that reduce swelling for the most part. They also are responsible for releasing adrenaline, which really stimulates that fight or flight response. Inside the thyroid, there are tiny little glands called the parathyroids, and those help to regulate blood calcium. The thymus gland sits right above your heart, and this is very important in the immune system. Your T cells, which are part of your immune response, are stored and mature inside the thymus gland. Your pancreas is found right behind your stomach, and most of you probably know that your pancreas is responsible for producing insulin as well as glucagon, and those 2 hormones help to regulate your blood sugar, especially after eating a meal. And then finally, this is obviously a male, and the testes, but in a female, the ovaries, these are also endocrine glands. And not only do they produce the sex cells, the sperm in males and the eggs in females, but they're also responsible for producing the sex hormones. Okay. Now, this is a Mr. Anderson video about the endocrine system. So I strongly recommend that you pause the video, open up the PowerPoint that's uploaded onto the Canvas, and watch this video, because it'll go through all of the various endocrine glands and the major hormones that they produce. Okay, so take a few minutes and do that. You can do it now, or you can do it when you're finished with this video. Okay. So for the end here, what I'd like to talk about are emotions and some of the theories of emotions that are currently out there. Okay. Now, emotional responses, and we're talking happiness, sadness, anger, you name it. These emotional responses are controlled by the autonomic nervous system, all right? Meaning that you don't have control over them. Now, you can bring your emotions into control, but that initial emotional response is automatic, all right? Happiness, sadness, anger, all right? An emotion consists of three major parts. There's a physical component, all right, where you have a state of physiological arousal triggered by your autonomic nervous system. Your heart might begin to beat faster. You might begin to sweat. You might laugh out loud. All right, you might begin to cry. These are all physical ramifications of that emotion. There's a behavioral component, which is an outward expression of your emotion. And this includes your facial expressions, smiling or frowning, movements, gestures that are triggered. And these are triggered by the somatic nervous system. Okay, so they're not automatic. They are voluntary responses to the emotion that you're experiencing. And then finally, there's the cognitive. Well, thank you, Jesus. Finally, there's the cognitive component, which is how you essentially think about the situation and figure out what emotion you're actually experiencing and how intensely you're experiencing it. Okay, so physical, behavioral, and cognitive, all three of these are very, very important aspects of emotion. Now, your textbook goes through four different possible ideas about how these three components are actually related. And these are referred to today as the theories of emotion. Now, the common sense theory of emotion is the experience of the emotion leads to physiological arousal and behavioral responses. All right. And so, in other words, there's a stimulus of some sort. Okay. You see, a lion standing in front of you on the path. Okay. And the common sense theory says immediately you're going to be afraid. Okay. And that's the emotional feeling. And that emotional feeling will then lead to the physiological arousal and the behavioral responses. And that might be the adrenaline from the adrenal glands, and your heart rate goes up and your sweat glands begin to sweat, and all of the other things that might be associated with fear. And then you respond behaviorally by running away or climbing a tree or doing whatever it is that you can do in order to get away from the lion. Now, two psychologists called James and Lang put forth a hypothesis that it was the physiological arousal and then the behavioral responses that lead to the emotional feeling. So, in other words, here you see the bear, the lion, whatever it happens to be, and your heart rate goes up and you start to sweat and everything else, and then you turn around and start running, and that leads to the emotion of fear. Right? I'm not really a fan of this theory, because it seems to me that the emotion has to happen first and then the response. All right, I look at it more as a cause and effect deal, but that's what the James Lang theory is. All right, the arousal and then the behavioral response lead to the emotion. The Cannon-Bard theory of emotion says that the stimulus causes the autonomic nervous system to produce a physiological response. All right, automatically, your heart rate goes up and you begin to sweat. And then the somatic nervous system produces the behavioral response, so you run away. And then again, the brain produces the emotional feeling. So all three in Ken and Bard, kind of all three things are happening at the same time as a response to the stimulus, right? The seeing of the lion. Finally, Schachter and Singer proposed that the stimulus leads to physiological arousal. All right, the heart rate goes up, and you start to sweat, and that leads to your cognitive realization that you're undergoing an emotion, and so then you have the emotion, fear, or whatever it happens to be. All right, again, in my opinion, it's probably the experience of emotion that leads to the physiological arousal and the behavioral responses, right? But who knows? These are all good theories. None have been proven, none have been disproven, but they are all part of the idea and the theories of emotion that you'll study in any good psychology class. So that, my friends, is the end of the second section of Chapter 2 in your textbook. So I hope that you learned something.